Okay, today is Unit 3, Day 1. We're going to talk about quadratic functions. Unit 3 and Unit 4 are actually all about quadratic functions. So if you love them, that's great. If you don't like them, sorry, we're going to be talking about them for a while. This unit is going to be mostly graphing them, and then Unit 4 is solving them. So kind of split it up that way. Today we're going to do, our learning target is I can identify quadratic functions in their graphs, so just be able to tell what one looks like. I can graph quadratic functions given in vertex form, and I can find the domain and range, axis of symmetry, and other properties of a quadratic from a graph or an equation. So first off, what is a quadratic function? It is a function that can be written in the form ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. Because if a was equal to 0, there would be no x squared term. The graph of these is a parabola, and a parabola is either a U-shape or it can be an upside down U-shape. So it's going to be one of those two for what we're doing. So first off, can I identify? So identify what kind of function is given, and then if it's a quadratic, state the quadratic term, the linear term, and the constant term. So on this first one, is this a quadratic? Well, is it written ax squared plus some bx plus c? It's in a different order, but it's still there. So this one is a quadratic. In the quadratic term, I'm just going to put quadratic, linear, and constant. I'm going to label those. The quadratic term is the x squared term. So negative 2x squared would be the quadratic term. The linear term is negative 3x. That's the term that has just x on it. And then the constant is 9. Okay, is this guy quadratic? Well, let's multiply it out and see. So if I distribute this x out, it would be x squared plus 3x. Okay, so yes, that is a quadratic. It has an x squared term, has an x. And then the constant here is not, it's plus 0. I could write that in there, but I wouldn't need to write it in there. And if I want to identify the quadratic, linear, and constant term, on this one, quadratic would be x squared, the linear is 3x, the constant is 0. The next one down here, now you look at this and say, hey, I see x squares and I see x's, so let's put down quadratic. But be careful, okay, so let's multiply this out. So this would be 3x squared minus 6x. Minus 3x squared plus 6. It'd be a plus 6 because you have negative 3 times negative 2. So that'd be a plus 6. And when I simplify here, I've got 3x squared and negative 3x squared. So those would wipe out. You just have negative 6x plus 6. That's not a quadratic because there is no a term here. Okay, there's no, or in this case, a is 0 because it's not there. So this is actually a linear function. Okay, that's a linear function, so don't need to name these things because they don't have them. It's not a quadratic. Next one, I got a binomial times a binomial, so I'm going to FOIL. So first, outer, inner, and last. Combine like terms. That's 5. And now so this is a quadratic. Quadratic. Has an x squared, an x, and a constant. And so the quadratic term is going to be 3x squared. The linear term is negative 16x, and then the constant is 5. Okay, so be able to name those. Next, given the following graph, so I gave you the graph, let's identify some key parts of this graph. So you may not know these yet, but we're going to answer them here for you or teach you those. So draw in and state the axis of symmetry. So every parabola has a line that goes right down the middle. If you look, the left side and the right side are mirror images of each other. So right here is an axis of symmetry. And right here is one for this guy. So we'll say axis of symmetry. So I'm going to say AOS, axis of symmetry. And then it says, and this would be, in this one, it'd be x equals, because they're vertical lines, so it's an x equals, and this would be 1. So if I said, what's the axis of symmetry? You say x equals 1, that line. If you graph x equals 1, that's the axis of symmetry. Over here, it'd be x equals negative 1. Next, find the maximum or minimum value. So in this case, every parabola has a minimum or a maximum, but not both. It has one or the other. So the minimum point, if you notice, it's on the axis of symmetry. So this one would be a minimum. And in this case, the actual value of this is -4. So when we say value, we're talking about the y-coordinate. We also want to know where it happens. It happens when x equals 1. So 1 comma -4 is the minimum. And then over here, I've got a maximum. And this one, its maximum value is 4. So I'll put max. The value itself is 4. It happens when x is -1. And notice the x-coordinate and the axis of symmetry are the same thing. X-coordinate, axis of symmetry, they're always the same. It's pretty cool. If you know one, you know the other. Intervals of increasing or decreasing. If I look at this guy, and this is kind of introduced in this part, if we said domain and range, we could do that too, but intervals of increasing or decreasing. If I look at this graph from left to right, what are the y values doing? So here, as I'm reading, like if I'm going left to right across, the y values are going down, 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 down. Here they bottom out at the minimum, and then it starts going up, 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 up. So this interval right here is the increasing interval. It's going up. So if I said the intervals of increasing, I want to describe which x values are the y values going up. So right here at 1 is when it started. And then as x goes to infinity, it just keeps going up. So from 1 to infinity, again, these are x values, from 1 to infinity, it's increasing. Notice I did include 1. And this is kind of a touchy subject for mathematicians, but we say, is it increasing down at 1 or is it decreasing? Increasing or decreasing? Well, some say neither and some say both. We're just going to say both. Our textbook says both, and that's kind of how we're going to go with this. So from 1 on, 1 included is increasing, but it's also decreasing at 1 too, because the point right before it has a higher value, so it went down, and then it's also going up right after it. So if this is increasing, this side is decreasing. It's going down. So decreasing would be from -infinity to 1. And on this one, I'm going to include 1, because we said 1's always included. Notice I never include -infinity or infinity because they're not numbers. So you can't include something that's not a number. It's just an idea. So we never include infinity or -infinity in our intervals. One thing that's not on here, but you do need to know for your homework is domain and range. Remember, domain and range is left to right. So this graph goes left forever, it goes right forever. So the domain would be -infinity to infinity. That just says you can plug anything in you want. Any quadratic, you can plug it in and find an answer. Now for this one, the range then, remember, think range is up and down. It goes up forever, but it doesn't go down forever. It stops right here at -4 on the y-axis, so -4. So it's going to start at -4 and go off to infinity. Okay. This guy over here, increasing, decreasing. It's actually increasing on this side, so it's increasing from -infinity up to -1. -1 is included. And on this side is the decreasing. So it's decreasing from -1 to infinity. We include -1, we don't include infinity. If you had to do the domain and range, domain would be -infinity to infinity. The range on this, now, it goes down forever, but it goes up to 4. So it goes up to 4. We always want to go least to greatest. I know some students do this. They say from 4 to -infinity. But that's not possible. You can't, because we got to go least to greatest. 4 is not less than -infinity. -infinity is the smallest number you can possibly come up with. So we need to go from -infinity to 4. Okay, so that's our answer. Down below, remember doing these. Last unit we did each one of these. We did absolute value, did square root, and we did squares. And we shifted them around. So think, what did, we'll say A first, what did having an A out here do? Well, it's one of these three. So maybe, actually, you probably pause right now and draw lines for all these. Draw a line from A to one of those. That's just a number. This should be 1, 2, 3. I'm sorry. for number 1, number 2, number 3, draw a line to where you think it goes to, and then come back and hit play. But yeah, so A has to do with the stretch or compression. That makes it taller or skinnier. The H is inside here. It's with the X. X has to do with horizontal movement, so that's a horizontal translation. And then the K on the end has to do with moving it up and down, so that's going to be a vertical translation. Okay. Now, this is actually supposed to be on the next page. I'm sorry, when I printed, sometimes stuff gets moved up or down here. So the vertex form, and I might just write that on the back side. I'm going to flip the page and write it on the back side. Okay, so here's where it's supposed to be. Now, because the vertex, in the very beginning, it's on the origin. Because it's on the origin, for the parent function, the parabola parent function, the vertical and horizontal translation gives the location of the vertex. Okay, so if you know where the vertex is, that tells you how far left or right, up and down you went. Or if you know vice versa, if you know how far up, down, left, or right to go, that also tells you the location of the vertex. So H comma K is actually the location of the vertex too. So the name of this is vertex form. If you got it in this form, it's screaming the vertex at you. It's telling you exactly what the vertex is. Okay, so here, if A is larger than 1, so if that's a positive number, it's considered a positive parabola, and it opens up. It's kind of a smiley face. It's going to be open up. It's positive. It's happy. Whereas if this is less than 0, meaning it's negative. So if A is negative and there's a negative out front there, it's going to be a negative, and it opens down. So it's negative. It's a negative person. It has a frowny face all the time. Kind of think of it that way. Okay. Now I'm going to kind of let's go a little faster with this because our video is getting to be a little longer than I want it to be. But now let's practice some of those shifts. So we did this last unit. We spent a whole day moving parabolas and square roots, and we spent a whole day doing absolute values. So hopefully this won't be too much. I'm going to do -2, 0, and 2. And if I plug those into the formula, I get 4, 0, and 4. So -2, 4. And if you plug in 1 squared is 1, -1 squared is 1, and you get that U shape. If you remember from last unit, I said do the origin, go up 1, right 1, up 3, right 1, up 1, left 1, up 3, left 1, and that's kind of that's the parent function. That's if there's no vertical stretch or compression. The vertex is at 0, 0. The axis of symmetry is at x equals 0. The domain would be -infinity to infinity. This one would have a range of 0 to infinity. Okay. Now, if you want to try these just from memory, maybe pause the video and try this out. But this right here, that would be a right 3, and that would be a down 2. So right 3, down 2. There's my vertex. So 3, -2, x equals 3. Goes through there, up 1, right 1, up 1, left 1, and then from there, up 3, right 1, up 3, left 1. Try to make it as much of a U as possible. Domain is -infinity to infinity. This range starts at -2 and goes up. So -2 to infinity, include -2. Increasing, decreasing. This one is decreasing. It's going down from -infinity to 3. Notice I'm including, these are x values, x values, x values, not y values. We're not worried about the actual y. Include that, and then it's, I wrote that backwards, it's decreasing. Let me get my white out. Okay, now it's increasing from 3 to infinity. So there you go. Okay, a little bit quicker here. Let's see, this is up 3. This means to flip it. I'll just put double arrow for flip it over. We're going to go up 3 units, so up 3 units. And now instead of going up, I'm going to go down. So down 1, left 1, down 1, right 1, down 3, down 3. There's my U shape. The vertex is at 0, 3. The axis of symmetry is x equals 0. The domain on this one, domain would be from -infinity to infinity. Range would be, again, think up to down. smaller to greater, goes from negative infinity up to 3. It is increasing from negative infinity to 0. Again, these are x values, x's. I'm going to describe the x's. Decreasing from 0 to infinity. Okay? And maybe just for the sake of the video, I might just do one more, and then I'll just cut it off, and I'll show you the answers to the rest of it. So in this one, this would be up 4. This would be left 1. This would be a flip. And then this is a horizontal compression. I'll put HC for horizontal compression, which means every point you had, if it's a factor of a half, it means it's going to be half as tall. So you're going to squish the thing down. So let's go, vertex is here, go up 4, left 1. I'm going to flip it over, so I'm going to be going down. I normally would go up 1 over 1. Because it's a 1/2 compression, I'm going to go up half over 1. Up half over 1. And then I used to go from here, I go up 3 over 1. Well, now I'm going to go up 1.5. So 1.5 over 1 would be here and there. So you see how I took it and I squished it. Okay, so now it's going to be kind of a wider parabola instead of a taller, skinnier parabola. Okay, the vertex is now at -1, 4. Axis of symmetry is x equals -1. Domain is, you guessed it, negative infinity to infinity. The range on this, and we're going from bottom up, so it'd be negative infinity up to 4. Increasing, decreasing, negative infinity to, I want x value, so the x value here is -1. And then from -1 to infinity, decreasing. Okay. So now I'm going to fill it. I'm just going to pause and fill the rest of this out. And you can, if you want to pause and try it out, you can, and then you can check it. So there's the rest. And don't forget, we're going to try this now. I'm going to try our learning log, which I'll explain that. If I haven't already explained it to you in real life, I'll explain that to you. Please just take a minute or two to update that too. Every time you're done taking notes or done doing homework, or if we take an assessment, go to your learning log and fill that out.